In this problem, the second order differential equation is given. For this equations, we need to calculate all time domain specification for unit step input. Here x of t is input and this y of t belongs to the output side. So for the solution of this kind of problems, first it's required to convert this time domain into frequency domain. Let us begin. So the given equation is here: y double dash of t plus y dash of t plus y of t equal to x of t. Well, so let us apply the Laplace transform to this LT2 above equation. LT2 above equation. Okay. So now after applying the Laplace transform to the above equation with the neglecting all initial conditions, so the y double dash t is become s square y of s into y of s plus y of s is equal to x of s. Let us take s outside. S square up till let us take y of s outside from this equation. Then we'll get s square s plus 1 into y of s is equal to x of s. Then the transfer function tf is equal to output divided by input is equal to 1 divided by s square plus s plus 1. So why I converted the given time domain into frequency domain is, as you know that all time domain specifications is actually required uh, this kind of solutions. That means, see, while calculating time domain specification, that is tr, tp, mp, ts, these are the time domain specifications. So before calculating, so we need to convert the given differential equations into the transfer function that is in frequency domain. So after converting this, we can easily calculate tr, tp, mp and ts. So look at this, the given transfer functions and what we calculated, that is s square plus s plus 1 and this transfer function, compare these two, then we'll say that the omega n, easily we can say that omega n is here omega n square is equal to 1, then omega n is equal to 1. This unit is in terms of radian per second. Next term is, that is 2 xi omega n equal to 1. Omega n is already 1, then psi is equal to 1 divided by 2, that is equal to 0.5, where psi is equal to 0.5. This damping factor don't have any units to express. So once we calculate omega n and psi, then it is easy to calculate TR, TP, MP and TS because these having only once we know that omega and damping factor, then we can easily calculate that time domain specifications. Let us calculate first TR, that means rising time. The rising time can be calculated by using this formula, that is pi minus theta divided by omega d, where theta is nothing but this formula is required to calculate, and omega d is nothing but damping frequency that can be calculated by using this formula. So let us begin the calculations of theta and omega d. Once we calculate the finding rising time and peak time is very simple. Well, so theta is equal to formula already given, directly I'll substitute the values, tan inverse of square root of 1 minus 0.5 square divided by 0.5. The answer of the theta is 60 degree. And one point how to remember here, theta is here we calculated in terms of degree, but here the rising time is having pi minus theta. Pi is in radians, theta is in degree. Usually this is the mistake what we do in the examinations. So please always keep the theta value in terms of radians. Well, let us convert this into radians, that is 60 into pi divided by 180. This is equal to 1.0472. Then and unit is radian. Okay, so next we'll calculate omega d. Omega d is nothing but damping frequency. Omega d is equal to, so omega n, that is natural frequency is 1, already we know that, then 1 into square root of 1 minus 0.5 square is equal to, the answer of this one is 0.866 radian per second. This is the answer of omega d. So once we calculate omega n, zeta, theta and omega d, so the next calculations is going to be very simple. Let us begin the first time domain specification, that is TR, where TR is equal to, already the formula is there, so I'll directly substitute the value pi minus theta. Theta value has to be in terms of radians, so therefore 1.0472 divided by omega d. The omega d value is already, we know that it is 0.866. The answer of the rising time is 2.418 second. Next is peak time, TP, that is equal to, the difference between TR and theta is only one thing, that is theta. So pi divided by omega d. Again I'm rewriting. So only theta value is missing. So let us say its value is pi divided by 0.866, that is equal to 3.628 seconds. Then after MP, peak overshoot. MP, usually this is expresses in terms of percentage, so therefore MP is equal to, directly substitute the value, e raised to minus pi into 0.5 divided by square root of 1 minus 0.5 square. Then in, because I'm expressing in terms of percentage, so therefore I'm multiplying 100. After calculating this, the MP value is 16.3%. And the last one, TS, where TS is called settling time, that is 4 divided by xi is 0.5 into 1. The answer of this one is 8 seconds. These are the values of time domain specification for given differential equation.